On this lesson, I will discuss some hints for some of the examples for lesson 77A. So, taking a look at test number 1, it says find the perimeter for each polygon. One hint for this type of problems is that you should be asking yourself this question: what type of lines is the perimeter of the polygon? Well, notice that here you can see that this is just a segment of tangent lines. So notice that you can think about these two lines as if they were tangent lines. Now go back to your lessons and try to recall what are some properties that tangent lines that meet on a point outside of a circle. Is there any relationship between these two lines? Task number 2. Think about what kind of properties does a four-sided figure have once it is inscribed inside of a circle. Taking a look at task number 3, it says find x given that the angle APB is 2x. So let's identify where that is. So APB, so this angle right here, has a value of 2x. ACD has a value of x. So ACD, here we have a value of x. And also in addition, the arc BC, which is this whole arc right here. Oops, I'm sorry. This arc right here is also x. So given all this, we want to find the value of x. Well, the first thing that you might notice is the following. Notice that there are two, let's erase that. Okay, there you go. Notice that given all that, one thing that you might notice is that here we have two inscribed angles. We have the inscribed angle B and we have the inscribed angle of C. But one thing that you notice about those two inscribed angles is that, at least for inscribed angle C, they do intersect at the arc of AD. And also, in addition to that, notice that the inscribed angle B, it also intersects at the same arc, AD. So therefore, recall that one of those properties says that if you have two inscribed angles and they intersect at the same arc, they must have the same measure. So given that, if ACB has a value of x and they intersect at arc AD, then therefore B should also have a measurement of x. Because if these two inscribed angles meet at the same arc, so therefore they must have the same measurement. So now that we know these two angles must have the same measurement, now think about the relationship between an inscribed angle and the arc. Well, since we know that the value for this inscribed angle is x, so therefore the arc should be double that measurement. So therefore we can represent this arc as if it was 2x. And what I want for you to think about is, can we properly find out the value of the angle of A? Think about it. Angle A, it's an inscribed angle. Is it possible for us to find out the value of angle A? That's my hint to you. Looking at task number 4, it says that we have a diagram which is a regular polygon with 7 sides. Now, we want to explain why the number of angles are all congruent. And the hint here is that we can assume that a circle can be circumscribed about any regular polygon. So what this is saying is that for any regular polygon, what we can do is we can take a look at all the vertex of this regular polygon. And we can construct a circle that will circumscribe, or that it will enclose enclose this figure. It's an almost perfect circle, but that's okay. Now, my question to you is, what's the relationship between this circle and the edges of the original regular polygon that was given to us? Is there any relationship between the edge of the regular given polygon in the problem and the circle? Think about it. Is there any relationship between the edges of this figure and the circle? You might want to use that to properly answer this question. For task number 5, think about what kind of an angle is ABC? And lastly, for example 6, my hint to you is, well, given that the instruction is when an inscribed angle cuts off an 80-degree arc, we say that the inscribed is a semicircle. Now, is such an angle necessarily to be a right angle? Now, my hint to you is this. Notice that if O is the center, then now we can think about as having two types of triangles. And they're not just any regular triangles here. Notice that triangle AOC and triangle COB are isosceles. They're an isosceles triangle. And since they're isosceles triangle, then now we know that angle A is congruent to angle ACO. And also, in addition to that, we can also assume that angle B is congruent to triangle BCO. And given this information, do we have enough information to make the claim that angle C is equal to 90 degrees? So that's my hint to you. You might want to show that angle C is the one with 90 degrees, therefore it is a right angle. So this video is not so much to teach you how to do some problems, but this video was more to guide you so you can properly think about the problems on this lesson.